Hello everyone. I'm going to do a few more examples of solving trig equations. In my first example, I have 2 times the sine of x times the cosine of x is equal to the square root of 2 times the cosine of x. As I mentioned before, the main thing we want to be able to do is isolate our trig function, so the term that has our trig ratio in it. We want that set equal to some value, and then we can use our unit circle or something similar to help us find the solution to our equation. Now in this example, I actually have 2 different trig functions. I have sines and I have cosines. So because of that, we are going to have to use a couple different algebraic methods to help us solve this. Specifically, we're going to have to factor. After we factor, as long as it's set equal to 0, we can use the zero product property to separate this into 2 different equations, and then hopefully from there we can find our solutions. So the first thing, let's get this set equal to 0, so I'm going to subtract this term from both sides. So 2 sine of x, cosine of x, and then we have minus the square root of 2 cosine of x. That is equal to 0. So 2 different terms, they both have a cosine of x in them, so let's factor that out. So if we do that, we are going to be left with 2 sine of x minus the square root of 2. And now since that's equal to 0, we have 2 terms here, or 2 factors that are being multiplied together. So we can use our property to separate this. So we have the cosine of x is equal to 0, or we have 2 times the sine of x minus the square root of 2 is equal to 0. We can finish solving the second equation. So here's the big idea again. We want to isolate the sine of x. So we'll add the square root of 2 to both sides. And then to finish isolating, we'll divide both sides by 2. Okay, so now we have 2 possibilities here. So the cosine of x is equal to 0, or the sine of x is equal to the square root of 2 over 2. The solutions to these 2 equations will give us the solution to our original. In this example, I just wanted to take a look at the solutions on the interval from 0 to 2 pi. So we can use our unit circle to help us with that. So when is the cosine of x equal to 0? Cosine of x is basically our x value. So when it's at 0, we have 1 here at pi over 2. And then we have another x value at 3 pi over 2. So for this equation, the angles that are going to give us a cosine equal to 0, we have pi over 2, and we have 3 pi over 2. And now for our second equation, when is the sine of x equal to the square root of 2 over 2? Sine is basically our y value, so square root of 2 over 2, so at pi over 4, and then the next time that happens, the symmetrical one over here, 3 pi over 4. Down here, these are both negative, so those are our only 2, pi over 4 and 3 pi over 4. So now we have 4 total solutions. So let me just group those together. So we have pi over 4, we have pi over 2, and I'm putting these in numerical order. We have 3 pi over 4, and 3 pi over 2. So within that interval from 0 to 2 pi, we have 4 different solutions. All right, let's take a look at a second one. 4 times the cosine squared of x plus 2 times the cosine of x minus 2 square roots of 2 cosine of x is equal to the square root of 2. So in this example, this is all cosines. However, we have cosine squared and we also have cosine to the first. So because they're different degrees, we can't just simply combine everything together. So we are going to have to factor in this case as well. So the first thing is I do want to get this set equal to 0. So to do that, all I'm going to do is subtract the square root of 2 from both sides. Now if I look at this, I have 4 terms here. The 2 terms in the middle, these both are cosine to the first, so we could combine those together. However, 2 and then 2 radical 2, those don't simplify too nicely. So instead, I'm going to leave this as 4 terms, because when we have 4 terms, we do have a method for factoring that should make this pretty straightforward. I'm going to do factoring by grouping here. So I'll group up these first 2 terms, and I'm going to group up the second 2 terms as well. And when I do that, I just want to make sure that the negative sign gets grouped up in my second group here. Now within each group, I'm going to take out a greatest common factor. So in this first group, what they have in common, they have a 2, and they have a cosine. So factor out 2 cosine from both of those. That will leave us with a cosine of x. And then factoring both of those things out, we're left with 1. And in the second group, it looks like we can factor out a square root of 2. So a negative square root of 2. Oh, this 2 cosine of x. So if I factor out a negative square root of 2, hopefully we want these parentheses to match, which is how I noticed I forgot the 2 back here. So both sets of parentheses, 2 times the cosine of x plus 1. So now we have another common factor. So bring that out front. So 2 cosine of x plus 1. And then we're left with a 2 cosine of x, and then the negative square root of 2. So factoring by grouping, and now we have 2 factors multiplied together set equal to 0. So we'll separate this into 2 separate equations. So there we go. And now we can finish up. So we went from having, the cosine squared, and we also had cosine to the first, 2 different degrees that we couldn't necessarily combine together. But factoring that down, now we have 2 equations where it's just cosine to the first in each of these. So for both these equations, we can easily isolate the cosine of x. This first one, so we'll subtract 1, divide by 2. So the cosine of x is equal to negative 1/2. And the second one, add radical 2, divide by 2. So cosine of x, square root of 2 over 2. So again, we have 2 equations here. We just want to figure out what values of x, when plugged into cosine, is going to give us this. So in other words, what angle is going to give me a cosine equal to negative 1/2, or equal to the square root of 2 over 2. And again, I just want to take a look at the solutions on the interval from 0 to 2 pi. So the first one, when is cosine negative 1/2? So here's the first one, 2 pi over 3. And then the symmetrical one, 4 pi over 3. So this first equation, we have 2 pi over 3 and 4 pi over 3. And then from our second equation, when is cosine square root of 2 over 2? We have one at pi over 4, and then a symmetrical one down here, 7 pi over 4. Okay, there are our 4 solutions. Okay, so in some cases, simple algebraic operations is not enough to isolate our trig term, and sometimes we're going to have to use factoring to help us do that. So if we have multiple trig ratios like we have in this one, or if we have all the same but we have some different degrees, we can use factoring and the zero product property to help us solve.